Today the topic of our study is selection sort. So first of all, what we are going to do is that we will learn about the selection sort. So in this video we are going to learn about selection sort. So let's say that we are given the following array. We want to sort it into increasing order. Let's suppose that this is our array which is not sorted and we want to sort it in increasing order. This is just the basic concept of insertion sort. We are not going to look into the code of insertion sort, but we are going to look into the main idea how insertion sort works. So during each iteration we will select the smallest item from the unsorted part of the array and move it to the sorted part. Iteration, obviously we do iterations whenever we do the sorting thing. So during each iteration, during each cycle, when we observe our array and compare the items and move the items from one place to another place, what we actually do, we select the smallest item from the unsorted part of the array. First of all, we consider that whole array is unsorted, but once we just keep on doing iterations, some part of the array gets sorted, and whenever we get the smallest item, we just move it to the sorted part of the array. We will keep track of the current minimum and the current item by using red and blue arrows like this. The sorted part of the array will be shown by the green boxes, and current minimum will be shown by the red arrow, and the current item will be shown by the blue arrow. So you will find it easier to keep track whatever is being done in the thing. So let's get started. First of all, just consider it that we have this array and our current minimum and current item is 2, because this is the first item of your array. So we set the first number as the current item and current minimum of the unsorted partition. Then what we do, we will progress in the array to look for even smaller number than 2. So what we will do, that right now 2 is the current minimum, but it was also the current item, but now we have to compare and we have to look in the whole array for the smaller number, even smaller than the 2. So this blue arrow will keep on checking all the numbers. First of all, it will see the 2, then 5, 3, 9, 4, 1. When it reaches 1, it finds out that 1 is smaller than 2. When this happens, what we will do, we find 1 at the end of the array, and as it is smallest, we set it as our current minimum. Now 1 is our current minimum, which was earlier 2, and it is also our current item. So what we need to do, we need to swap this 1 with 2. We will do the swapping, and once this 1 is in the first place of the array, the leftmost item, this is sorted one, because this is the smallest item and it is on the leftmost block, so it is sorted item. Now that is why we colored it green. Now we will do all the comparisons in the unsorted part, that is the white part of the array. So again we are going to do this. Now 8 is our current minimum and our current item, but when we will move next, we will see that 5 is smaller than 8. That is why it is also current minimum. When we will move more next, we will see 3 is smaller than 5. So red arrow will move to 3. Similarly, when we will go to 9, it is obviously greater than the 3, then 4 is also greater than 3. But when we reach 2, we see that 2 is smaller than 3. That is why now 2 is our current minimum. Now 2 is our current minimum, so we need to swap it. So we will swap the 2 with the leftmost block of the unsorted array. So when we will swap it, it will be again as it will be the part of sorted array. Now 1 and 2 are sorted array, and these 5 items are unsorted array, and we will keep on doing the iterations and we will keep on doing the comparison. So we are ready for the next iteration. Now we have 5 is again the current minimum and the current item. We will move to 3. Now 3 is smaller, so that is why 3 is current minimum and the current item. Now you can see that 9, 4 and 8 are also greater than 3. So that is why this blue arrow will also compare 9, 4 and 8. It will go there, but at last it will find out that 3 was the smallest number. So that is why I just skipped all these comparison, and I just say that as 3 is the smallest, so right now 3 will be swapped with 5. And again you can see that 1, 2, 3. Now we have a sorted partition which has 3 items. Then we go to 5. 5 is current minimum and current item. It is being compared with 9. When it is compared with 4, we find out 4 is the smallest, so it is compared with 8, and at last 4 is being swapped with 5. Then 9, obviously 9 is greater than 5, but 5 is smaller, so it is current minimum. It is smaller than 8, that is why 5 is swapped with 9, and now we have a sorted partition. Then 9 is compared with 8. 8 is smaller, so that is why 8 goes here. And at last 9 is the current item. It is the smallest item, so it is also the part of a sorted array. So in that way our whole array is being sorted out. So it is pretty simple. With each iteration you select the smallest item that hasn't yet been sorted, and you just pick it up and you just put it on the leftmost block of the unsorted partition. You can see that we have shown the sorted partitions with green, and we do not do any comparison in the green boxes, and we are just concerned about the unsorted thing. So this is the pseudocode for our selection sort, and you can see that we have 2 for loops. So whenever we have 2 loops, it simply means that what would be the time complexity? It will be big O of n square, and n is the size of input. I hope this idea is very clear, that how n square complexity of this sort is, but because we discussed it in our earlier videos. But how we calculate the complexity of sorts, we will discuss this in the coming videos in very detail, when we will be looking at the pseudocode and the algorithm, and maybe on the codes as well in very detail. So thank you very much. Please give your feedback.